Welcome. This is Multiplying Polynomials 3-6, and in this unit it should be pretty much review a little bit bigger polynomials and a little bit bigger degrees than what you've had in previous, but I don't think it'll be difficult. This particular way that they show it, they don't necessarily mention box or FOIL. They just make sure that you're multiplying each term in the first polynomial with each term in the second. Here I would just distribute. And they like you to show your work by placing those two together, the first two terms, then this term with the second term here. Now realize that sign goes with the second term, and then this term with the third term here. And then you go ahead and you give the product. So 4 times 2 is 8, and then you add your exponents. 2 and 3 is 5. 4 times -1 is -4, and you add your exponents, x to the 4th. 4 times 5 is 20, x squared. And there's your answer. Now, if you have a binomial times a trinomial, so for example, in this case, we have a binomial, 2 terms, times a trinomial. Again, you just make sure that this term multiplies by each of these, and then this term, -3 is the term, not 3, multiplies by each of these, that negative included. So you make sure that you're multiplying each term by each term. Now, it is fine if you prefer over here in the margin to make a 3x2 box. Write your binomial x, -3, your trinomial -x squared, +2x, and +1, and then you multiply these, adding their exponents. 2 and 1 would be 3, a negative and a positive is negative, so -x cubed, x to the first, that'll be x to the second. 2 times 1 is 2, x times 1 is 1x, you can just write it as x. -3 times x squared is -3x squared. -3 times 2 is -6. Then there's an x. -3 times +1 is -3. Now, when you do it with a box like that, your like terms, if you've put them in standard form, your like terms are always diagonal to each other. So you can combine those two. So we'd have a -x cubed, -3x squared, and a +2x squared would end up being a -3x squared. So we would have, don't know why they put a plus there. Let me make sure that I'm going right. Looks kind of funny for a minute. Oh, I see. I see why. Hello. A negative times a negative is a positive. So that is a +3x squared. So +3x squared and +2x squared would be a +5x squared. X and a -6x would be a -5x, because this was positive, you subtract them, and then -3 is left at the end. So you can do it either way. You can do like they've shown here, where you rewrite first term with each of the terms, and then last term with each of the terms, and then distribute them to each other and work them out and combine them. Or you can do box method. I also show you in class how to do clamshell, so I wouldn't miss class right now. I'd make sure and get all my techniques. Use vertical arrangement to multiply. This is just like when you used to multiply 36 by 18, for example. You would take this first one, multiply it 48, carry it, 8 times 3 is 24, plus 4 is 288. And then you come down and you move it over one place, because that's a tens. It's in the tens place, so you move it to the tens place. 1 times 6 is 6, 1 times 3 is 3, and then you add them. Same thing in this process. So just another way to multiply. So 3 times 1 is 3, 3 times 2x is 6x, and that is a negative 3. So negative 3 times 1 is negative 3, negative 3 times 2x is negative 6x, negative 3 times negative x squared is positive 3x squared. Then we go to the second term and we move over one place. X times 1 is 1x, x times 2 is 2x squared, and x times negative x squared is, add their exponents, negative x cubed. Then we add them. Negative x cubed, 5x squared, 6 and 1, 1's positive, 6 is negative, so that would be negative 5x left, and negative 3. So two different ways to do those. Okay, is the product of two polynomials always another polynomial? Yes. It's always another polynomial, just like we discussed yesterday with adding and subtracting them. It's closed for polynomials. If one polynomial has m terms and the other term has n terms, how many terms does the product of the polynomials have before it is simplified? Well, let's go back up here and look at this. We have 2 terms and we have 3 terms. And if you think about it as a box, it's a 2 by 3 box, we will have 6 terms in there before it's simplified. So it's 6 terms because there's 2 terms times 3 terms. So it's a good way to make sure if you're not using the box that you have 6 terms before you simplify, or however many terms there is term numbers in the factors that you're multiplying. Okay, there are several spatial products. Trying to avoid that shadow. I'll see if I can get that fixed on the next filming. There are several spatial products that occur so frequently that it is helpful to recognize their patterns and develop rules for the spatial products. So we've already done this one quite a bit. The sum and difference. We have a plus b times a minus b, and that's the difference of 2 squares. When we have a perfect binomial square, it ends up becoming a perfect trinomial square. And you can see that a is squared, the b is squared, then you just add the terms twice for your inside-outside to get the 2ab. Or if it's a minus, then it would be a negative 2ab. And then the cube of the polynomial, we're going to learn a lot more about that in upcoming times. So let's practice with some of these. So if we multiply conjugates, as we learned about in an earlier chapter, then we end up with the first, a times a being a squared, a times negative b being negative ab, then b times a, if we put it in the same order as this one, it's a positive ab, and then b times negative b would be a negative b squared. Negative b squared. So these two cancel, and we have a squared minus b squared. Difference of 2 squares. We've had quite a bit of exposure to that one. On the next one, we're going to do this again. Rather than go through all the middle terms, we know that it's the first term, 4x squared, and we're going to square it. We know it's the last term, 15, and we're going to square that. So whatever the term is there, you can bring it down and square it. Whatever the term is there, you bring it down and square it. Now, a requirement for it to be a difference of 2 squares is they have to be identical terms, just opposite sign between the binomial. So now 4x squared, 4 squared is 16, x squared would be x to the fourth, minus 15 squared is 225. And make sure you've memorized the list of perfect squares. Ask me for them if you don't have them any longer. Very first day I explained that we need to start working on memorizing those. They will make your life much easier. Okay, down near the bottom of this, a student was asked to find the answer of 7x plus 3, find the square of 7x plus 3. The student quickly wrote 7x plus 3 squared equals 49x squared plus 9. Identify the error and provide the answer. Well, you notice that the only time that we end up with a binomial in doing anything with these binomials is up here when it's the difference of two squares. He did not realize that this isn't conjugates. So you really need to FOIL that out. You really need to write 7x plus 3 squared is equal to 7x plus 3 times 7x plus 3. And then you FOIL or you box it. Go ahead and do that. You need to have the answer there for me. Show how to justify the rule for the cube of a binomial. Okay, the best way to justify that is to actually take a plus b cubed and expand it out. Now when you expand that out, I would FOIL the first two or box them. You'd get a squared plus 2ab plus b squared. Now take this and either put it in a 2x3 box with this one or do a clamshell, making sure that you, that should be an AB. Making sure that you multiply the a by each of these terms and the b by each of those terms and combining your like terms. You need to show the work for that and come to class with questions if you have some. Okay, recall that the Pythagorean triple is a set of positive integers, a, b, c, such that a squared plus b squared equals c squared, Pythagorean triple. A good example of that is 3, 4, and 5. Those are Pythagorean triples. So if we square 3, square 4, it will equal 5 squared. That's what makes them Pythagorean triples. Okay? So Euclid's formula states that if x and y are positive integers, with x being greater than y, then x squared minus x squared, y squared, 2xy, and x squared plus y squared form a Pythagorean triple. Okay, so they're just giving us a formula as to how we can find Pythagorean triples anywhere in the number system. Okay. So the next thing that we do is they want us to show that x squared minus y squared plus 2xy squared is equal to the x squared plus y squared squared. Okay, so we simplify the left side. We come over here and we're going to just simplify this side of the equation. So we take, and we're going to square this out. Okay, so we could put it in a box and go, make sure I'm on camera, okay. Go x squared minus y squared times x squared minus y squared. X squared times x squared would be x to the fourth. So right here, they're having you square the x's. You'll get x to the fourth. Now we have a negative x squared y and a negative x squared y. I should say x squared y squared. So that's where we get two of those. 2 negative x squared y squared. Okay, and then the last thing is negative y squared is squared. So we get a positive y to the fourth. Okay, so we have x to the fourth minus, right here you can see it, two of them, 2x y squared. And I probably shouldn't have put the minus with that one because it'll confuse you where we already have it up there. Then we have negative y squared times negative y squared is positive y to the fourth. Okay, that's the simplified version of that. Now, because of our formula up here, we need to square the 2x squared y squared. So 2xy times 2xy equals 4x squared y squared. So x squared minus y squared squared plus 2xy squared is x to the fourth back it back up here. I made just a little mistake. These are x squareds. Negative 2x squared y squared. And a positive 4x squared y squared would be a plus 2x squared y squared. And then we have the plus 4y. Or, I mean, plus y to the fourth. Okay? Simplify the right side of the equation. Now we're going to take this side and just simplify it. So we're taking x squared plus y squared, putting it in a binomial, x squared plus y squared. X squared times x squared is x to the fourth. X squared, y squared, x squared, y squared, and y squared times y squared is y to the fourth. Okay, so x squared twice is what they're saying there. Then here they're wanting to take both of these, so it's an x squared, y squared, and then the y squared squared. So our final answer is right off the box, x to the fourth plus 2x squared, y squared, plus y to the fourth. So we show that the left side of the equation is equal to the right side. That makes it a viable formula to use. Okay? It says compare the expressions of both sides of the equation. The expressions on both sides of the equation are equal. They are x to the fourth plus 2x squared y squared plus y to the fourth. Okay? Use the formula to generate a Pythagorean triple with x equals 5 and y equals 3. Okay? So basically, we're wanting to find what our triple would be with 5 and 3. Doesn't really matter where you plug them in at. Oh yes it does. The x is 5, the y is 3, so we plug in 5 squared minus 3 squared, that'd be 25, minus 9 is 16. Now we take 2 times xy, so 2 times 5 times 3, that would be 2 times 5 is 10, times 3 is 30. Now we say x squared, 5 squared, plus 3 squared. 5 squared is 25, 3 squared is 9, 25 and 9 is 34. So a Pythagorean triple could be A 16, B 30, and C 34. So basically what you're doing is this is your A value, this is your B value, and that's your C value once you plug a value in for x and y. Describe how you can check the Pythagorean triple and then perform the check? Well, you could take a squared plus b squared equals c squared and make sure that it's true. So we have a squared is 16, b is 30, and c is 34. I would grab a handy dandy calculator and punch in 16 squared equals 256. 30 squared is 900, one of those that I told you to memorize. 34 squared is 34 squared. 1156. Now we add these two. 6, 5, 2, and 9 is 11. So it sure does come out as the same triple. Okay, Pythagorean triple. 16, 30, and 34. Okay, in class tomorrow we will do the practice. Thank you very much.